This video was made possible through a grant from the Haas Corporation. The Geek Group would like to thank Haas for their continued support in helping encourage innovation in design and manufacturing in America. The Geek Group proudly features ISCAR tooling in all of our workshops, videos, and hackerspaces around the globe.
Operating the CNC machines in this video risks personal injury and mechanical damage. Hazards may include electricity, untrained operation, airborne toxins, flying debris and noise, fire and explosions, poor shop upkeep, sharp tooling, projectiles, loose clothing, inadequate clamping, automatic operation, automatic tool changer, lack of enclosure, and impact.
Hi there guys, I'm Chris Bowden and welcome to the Geek Group. I'm here today with my very good buddy ISCAR Rick.
Hi, how you doing?
Are you indicating?
I am indicating.
Okay. Today we're going to teach you the basics about thread milling. Now, thread milling is a really cool thing. A lot of people out there have drilled and tapped holes, and you're used to using something where you have to drill a very specific size hole, and then you run a tap, like let's say you're doing a really common thing like quarter 20. We got to drill a number 7 hole with a number 7 bit, and then a quarter 20 tap. You run that through the hole, and you get a quarter 20 tapped hole.
It's a 201.
Well,
201 is the decimal point for it.
Oh, I didn't know the decimal. I was doing number 7 bit.
Yeah, it's a 201.
But that only works, that tap only works with that hole, and you have to have that specific drill bit, that specific hole, that specific tap, and that's all you ever get. Well, there's another way to do it, but you have to have a different tool and a very smart machine. And what that is thread milling.
These are smart machines.
These are smart machines.
These are smart machines.
We have smart tools and smart machines and smart people, so we're good. This is a thread mill. Now, what a thread mill is it's kind of like a tap, but only a little tiny bit of a tap. You can see there's only teeth on the one side here. It's only got one insert, and it's got the teeth on it to cut that thread pitch in any diameter hole you want. It could be a 1-inch hole or a 10-foot hole, and as long as the machine's capable of doing it, it doesn't matter. This machine could do a 3.5-foot hole, no problem, and tap it 4 inches deep, and it's totally cool.
Sure. And you talked about big ones. We can do little ones too, all the way down to 0.80, smaller than eyeglass screws.
You can thread mill smaller than eyeglass screws.
That's correct.
What's the biggest?
We make a 4-inch diameter for doing like bridge bolts. So we are a full range supplier.
4-inch diameter.
No, the cutter body. This here
body?
is about 700,000, 3/4 of an inch.
Okay.
It's 4 inches in diameter, and it has 6 teeth on it.
It's got to be like a Cat 50?
Yeah. Well, that's just the head, and you put it on whatever.
Oh, okay.
And then you have 3 threads per inch instead of 11.
Okay.
It literally looks like a bear claw. Yeah.
I want one of those inserts. I want one. Just on my desk.
Hang on, we actually make inserts that are helical and spiral and helical all in one piece of carbide. So take a vertical, lay it over, and then wrap it around the diameter.
How did they make that?
It's ISCAR. We have the best mold technology. No, I'm serious. We have the best mold technology on the planet.
That's awesome.
Yep.
You've indicated the circle.
All right, so we're
in
above
position.
it. Yep.
All right, and we're perfectly concentric to our circle.
Yes.
Now, this is kind of weird because we don't have offsets and everything for the circles. We're actually retrofitting our vacuum table.
That's correct.
Because we made the table out of high-density polyethylene, and we're trying to get PVC pipe in there, and good luck trying to glue PVC pipe to HDPE. So we're thread milling this with FNPT threads.
No.
NPTF threads. They're FNTP.
No, they're not.
It's on the bag.
Yeah, I don't care what's on the bag. You look on the ISCAR website.
Oh, and that's the gospel. Oh, well, yeah, okay.
All right.
So we've got our threads, we have everything set up, and I'm going to glue a threaded male fitting on the end of our pipe for the vacuum table.
And that should solve all your...
Yeah, it'll just thread it right in.
You won't have a leak there.
Yeah, it won't leak. It's great.
Right.
All right, so here's your tool.
Gee, thanks.
Now teach people how it works.
All right, you want to single block through this so they can actually see it?
Yeah, we'll take it step by step through the first one.
All right.
Do we want to simulate it in air above it, or you just want to go right in?
No, we can go right in and do it.
Do it then.
Do it.
Rock it.
Oopsie, stop. Okay, we come down to our Z. We're going to go to our final depth. We move in, pick up comp. We're going to arc in all the way around, one continuous circle. That's our G3 with our I minus.
Okay.
That's one full circle. Now we get to this point here, we're going to arc out. Here's our arc out with a little bit more in the Z. Move back to center, cancel comp, and out of the hole, and we are done.
Okay, now
That's it.
why did we have to arc in and arc out? Why can't we, because we've done circular interpolation before.
Sure.
And we just went over and,
Well, the threads are in a spiral.
okay.
Right, so the threads have an angle to them. If you were to bring the tool straight in,
Hang on. The threads have an angle to them.
that's correct. They have a pitch. It is
Are the teeth on here angled?
No, they are
How do you
straight.
do that?
That's why we have to arc into it. We have to move into the ramp. All right. That's
Okay.
All right. The ramp is a constant
But
spiral.
there's teeth on here, and these teeth have width. I mean, that's
Actually-
almost a 1/4 inch wide.
That's correct. If you spin this, if you look at this closely and you spin this,
Okay.
you can't. Usually on, if I had a thread mill, you see it. But if there's more than one teeth, you look at it, all you see is just the V's. If you spin a tap, it barbershop pulls.
Yeah.
All right. This doesn't. These are just straight teeth. The teeth get the software in the machine move the tool.
I understand, but and I understand how the teeth have to be flat.
Right.
But if you're cutting a thread and the teeth are flat and they have width,
No, we're working on a point. That if you look at the tool real closely,
okay.
there's an undercut in there, and it's a very sharp
Oh,
point. It's
so-
all back cut.
okay.
There is no
So
healing.
There's no, that whole 1/4 inch width here isn't
Doesn't
all in
touch.
contact.
No,
it's
just
the
the
very
tip.
end. Okay,
Yeah. Yep.
okay. That makes sense.
Okay. Oh, you were worried about the whole backside.
Yeah,
healing.
I was like the whole backside.
Yeah. No, it doesn't. Yeah.
What do they call that?
Heel.
Healing.
Yeah, the heel's on the back. You got your toe and your heel.
Okay.
Same on it. That's how they call it.
Cool.
Okay.
I just learned something.
All right. Good.
All right, so
We're done.
we're done.
That's
it?
That's it.
It's that simple.
Well, yeah.
All right, so let's take a minute and go through the code and show people what's actually happening.
Okay.
Okay.
All right, so there's our program number, and we'll start out with our G90, which puts us in
Incremental mode.
no, that's absolute.
Oh, absolutely.
Yep,
okay.
we cancel.
91's incremental.
That's correct.
Okay.
G80 cancels any can cycles that might be there, but we're going to put it in G54. That's from the Department of Redundancy Department. They automatically do this in the houses, but this is just old school in me.
Okay.
All right.
But that's G54 is your offset.
That's
your
correct.
Work offset.
Work offset.
Okay.
All right, tool 1, obviously. Tool 1, M6, tool change.
Okay.
Okay.
So if you don't have one in it already,
It
it'll
will
go and
put
load
one
tool
into
one.
it, yes.
Okay.
All right, GO is rapid. GO spells go. And since we already picked up our G54 for a position, we're going to move to X0 and Y0. M3 spindle forward, and we're going to spin the spindle at 5,000 RPM. Okay, G43 says we're going to pick up a height offset. Which one are we picking up? We're picking up number 1.
Okay.
And where do you want to go with that? I want to go Z to 100 thousandths above the part,
Okay.
which I set in this height offset. Okay? All right, so then the part's going to be 500 thousandths, 550 thousandths deep. So we're going to feed, G1 means feed. We're going to go to Z minus 550 thousandths, and we're going to do that at 25 inches a minute.
Okay.
Okay? When we get to the bottom of the hole, now we jump to G91.
Okay.
G91 is an incremental move. So we're going to go X in the positive direction, 294 thousandths, Y minus 294, and in the meantime, we're going to pick up cutter comp. That's G41. All right, it's for wear or adjustment. In this case, it's adjustment.
Okay.
All right, and so we pick up G41, diameter offset number 1. All right, so now that we've picked up and we've moved off 294 thousandths in both directions, now we're going to arc. We're going to 294 thousandths, and then Y 294 thousandths, and this is our arc, 294
So
thousandths.
it's a radius of 294.
That's correct.
Okay.
At this point here, this Z is actually 1/8 of the pitch. So the pitch divided by 8 is that number.
Okay.
That gives us a good ramp in.
So we're doing 11 threads per inch, and that's our thread pitch.
11.5 threads per inch.
Ah, okay.
All right. Okay. Now we're going to do a G3 with an I minus 592 thousandths and 5/10.
Okay.
That's going to make a 360-degree arc. And this position is at 3 o'clock. We move to a 3 o'clock position. We're going to make a full arc. We're going to go counterclockwise all the way around the clock back to 3 o'clock.
Okay.
And we're going to move one pitch, one
Okay.
thread pitch. All right. Now that we're back at that point, we're going to continue with a counterclockwise arc. We're going to go X in the minus direction, Y in the positive with another arc. And that also is 10 thousandths and 8/10. All right, so we did our arcs. We arced in, or arced out, and our Z, that brings us out of it. Now we're going to go back to the center. So we're going to G1, since we're out of the G3s, arc, we have to give it a G1 value. G40 cancels the cutter comp. So on your way in, delete or shut the cutter comp off.
Okay.
We're going to go to X minus 294, Y minus 294. And if you were to follow all this through, everywhere we went, plus, minus, plus, minus, plus, minus, at this point here, we are back to our XY0.
Okay.
All right, so you got to remember where you were, okay? All right, and then when we're done, we go GO, which is a rapid, G90, puts us back in absolute, and from that point there, jump up 4 inches, shut the spindle off, and the program.
Excellent.
Yep.
That's awesome.
That's it.
And we have a beautifully threaded hole.
You have a beautifully threaded hole.
All right, you guys have fun. We want to thank you for watching the Iskar Haas video series here on the Geek Group. I'm Chris Bowden.
I'm Iskar Rick.
You guys have fun. We'll see you next time.
This video was made possible by a grant from the Future Girl Foundation.
This video was made possible by thousands of private donations from members and viewers like you. Please visit thegeekgroup.org for more information on how you can donate and become a part of our dreams of Avalon.